Hello! In this video, we are going to prove the following theorem. Let a be a non-zero real number. Then for all integers n, the absolute value of a to the power of n is equal to the absolute value of a to the power of n. So, to prove this, the property of absolute values that's going to be useful is the following. For all real numbers a and b, the absolute value of ab is equal to the absolute value of a times the absolute value of b. Now, let's remind ourselves of some of the properties of integer exponents that we have proven. First, let a and b be non-zero real numbers. Then for all integers n, ab to the power of n is equal to a to the power of n times b to the power of n. Second, let a be a positive real number. Then for all integers n, a to the power of n is a positive real number. And finally, for all integers n, negative 1 to the power of n is equal to 1, or negative 1 to the power of n is equal to negative 1. In fact, if n is even, then negative 1 to the power of n is 1. If n is odd, then negative 1 to the power of n is negative 1. So now let's get into proving this theorem. To start out the proof, let's give ourselves an arbitrary integer n. Now, since a is a non-zero real number, we know that the absolute value of a is a positive real number. So since absolute value of a is a positive real number, then by lemma 2, it follows that absolute value of a to the power of n, right? The guy on the right-hand side is a positive real number. Now, another thing is, by lemma 3, we know that negative 1 to the power of n is equal to 1 or negative 1. But no matter which one it's equal to, the absolute value of negative 1 to the power of n is equal to 1. Now, let's show that this equality is true. To show that, we're going to split this up into two cases. Either a is greater than 0 or a is less than 0. And in either case, we're going to show that this equality is true. So let's start with the case that a is greater than 0. Well, then the absolute value of a is equal to a in this case. So we can write absolute value of a to the n equals what? We can replace the base a with absolute value of a. So this is absolute value of a to the power of n. But since absolute value of a to the power of n is greater than 0, its absolute value is just absolute value of a to the power of n, right? We can just drop the absolute values because absolute value of a to the power of n is greater than 0. So that's it. As you can see, we have shown that this equality is true. So this completes the case a is greater than 0. Now let's consider the case a is less than 0. Well then, the absolute value of a is equal to negative a in this case. Or in other words, a is the negative of absolute value of a. So what we can do here is we can rewrite this quantity, take the base, replace it with negative absolute value of a. Now, negative absolute value of a is the same thing as negative 1 times absolute value of a. So then, applying our first preliminary result, lemma 1, we can rewrite the inside as negative 1 to the power of n times absolute value of a to the power of n. But then applying our fact about absolute values, we could split this up as a product of absolute values just like this. But absolute value of negative 1 to the power of n is equal to 1. So that first factor is 1. And again, absolute value of a to the power of n is greater than 0. So its absolute value must be absolute value of a to the power of n. And that's precisely absolute value of a to the power of n. That's it. Through this chain of equalities, we have once again showed that this equality is true. And that's it. This completes the proof. And so yeah, that's pretty much it for this video.